video goes with Unit 12, which is thermodynamics. The essential questions are: what is the law of conservation of energy and how does it apply in chemical reactions? What is the difference between heat and energy? And what are the three processes of heat transfer and how do they work? So we're going to start with the conservation of energy, which means that the total amount, if you added up all the energy in the universe, that it's going to be the same all the time. And that means that energy is conserved. You learn this rule as energy can either be created or destroyed, so you should remember that. Okay, so when we say it cannot be created or destroyed, that is true, but it can easily be transferred from one type of energy to another. So just to review, we have two main types of energy, that's potential and kinetic. Potential, we have several little subcategories there. We can have chemical potential energy, gravitational potential energy, electrical, nuclear, or elastic potential energy. On the kinetic side, you can have light energy, electrical energy, sound, thermal, or wind energy. So those are just some examples of types of energy that have motion. So if we apply this to chemistry in a chemical reaction, look at the energy transformation. If you look, what we're doing is taking two separate atoms and making a bond. And the green bar is going to represent the potential energy, which is in the form of chemical energy. And the blue bar is going to represent heat and light energy, which is our kinetic energy. If we look at the beginning, those atoms have a lot of potential energy and not very much kinetic. As the reaction goes on, they lose a lot of potential energy, but they let it off in the form of heat and light. So if you add the two bars together, before and after, they both hit that red line, which means that they're both the same, and so the energy is remaining constant. When we talk about these, we talk about open and closed systems. So just to define what that is, an open system allows matter and energy to be exchanged to the surroundings. And a closed system allows energy to be exchanged, but it doesn't allow the matter to exchange. So this means energy can come and go. And an example here is the Earth. It's not exchanging matter, but it is taking in solar radiation, letting off radiation from the Earth, and within the boundary of the atmosphere. Energy can be transferred by work being done. For example, friction over a distance would be a way of energy being transferred. Okay, so let's look specifically at thermal energy because we're talking about thermodynamics in this unit. And we want to know why object A feels hot, which is at 80 degrees Celsius, and why object B feels cold at 10 degrees Celsius. So we know that temperature mean hot and cold, but really what's happening with the energy there. If you look at object A and look at the white arrows there, you can see that they're heading outwards. And so that gives us a perception of heat because the thermal energy is going from the object into our hand. In contrast, if you look at B, the arrows are going inwards, and so that gives us the perception of cold because heat, thermal energy, is leaving our hand and going into the object. So heat is an energy that is transferred and it flows. An object cannot have heat. It's a flowing phenomena, and it goes from high temperatures to low temperatures. The unit of measure for heat is the joule because heat is a type of energy. And that's how we measure energy. So once again, to review, which direction is thermal energy transferred? Again, it's from hot to cold. So if we look at what temperature is, because obviously this is related, it's related to the kinetic energy. It's a measure of the average kinetic energy within an object. And when we're talking about that, we're talking about the molecules. So if you look at the blue side, those green circles are representing molecules, and they're not moving very much. So if they have low movement, they're going to also have a low temperature. The less they move, the lower the temperature. On the right, we have a lot more movement, and so the temperature is going to be higher. So why would that thermal energy go from high to low? Okay, if we think about the molecules and what's happening, the hot objects, they're moving faster with the molecules, and they're going to have a lot more collisions. When they come in contact with something cold, those hot objects collide, and they start that vibration of those particles, and that transfers kinetic energy throughout the cold object. And so this is an example of that. We start in the corner with the one barely vibrating and it's spreading out as it moves. So how can heat be transferred? There are three basic ways. The first is conduction, and this tends to be transferred through solids, or it could be a solid and a liquid. It happens when there's a collision between particles and objects in contact with each other. So that's the key that you have to look for, is that they are in direct contact. The second way is convection, and convection happens in liquids and gases, okay? And so it's transferred through the flow. So convection creates a convection current. So if you look on the right, there's an example of a convection current in a liquid with water boiling. So the hot water rises and it goes up to the top, and then it cools off when it gets to the top, and then it falls back down, and it creates that circle moving of molecules moving. Okay, that can happen in gases too, like on the candles on the right, and that convection current is a key feature of knowing that convection heating is happening. The third type is radiation, and that is when we have thermal energy transferred in waves. Okay, so some examples of this are sunlight, UV rays, infrared. Those are all ways that we can travel in waves. So if we look at an example of this candle, we can actually see all three types of energy transfer within this. So if you look at the top, we have convection because we have the gas coming off the top of the candle, and it's going to make a convection current. It's going to rise, cool, and fall back down and get heated up again. The radiation is coming from the light that's traveling in waves. And then the conduction at the bottom, you have that solid candle that is heating up as well. So you have all three there. So now why don't you check yourself? So we have 1, 2, and 3. Take a second and decide which one's which. Okay, and if you want to check now, number 1 is showing the convection current within the boiling water. Number 2 has direct contact with a solid, so that's conduction. And number 3 is showing the radiation from the waves.